Section 1.4 deals with two really key pieces that are, we call them foundational pieces for algebra. So the first one that we're going to deal with is the distributive property. What the distributive property tells us we're going to do is we're going to multiply anything inside of parentheses by the outside of the parentheses. So like if we were going to draw some pictures here, for example, in example 1, we have 6 times the sum of 8 and 10. Well, we're really going to take 6 and multiply it by 8 and 6 and also multiply it by 10. In this particular problem, a lot of people go, well, I'm just going to do 8 plus 10, that's 18 times 6. But you may not be able to do that in your head. So you know 6 times 8, that's 48. And you know 6 times 10 is 60. That's going to be a lot easier to do sometimes in your head. Not always. But when you look down at example 2, when we have an unknown, a variable, we can't add the stuff in between the parentheses because we're missing an unknown. So we might be able to simplify it a little bit, but we have to take care of the stuff inside the parentheses and multiply it by everything outside the parentheses. So again, I'm going to draw some arrows here. We're going to multiply -2 by this entire first term. We're going to take -2 and multiply it by the entire second term. And we're going to multiply it by the entire third term. And that's what they're showing you here. Here's your first term, here's your second term, here's your third term, that -2 is distributed to each of those. So when you're showing your work for this one, the first few problems you're just multiplying. But when you get, for example, like our number 5, you're going to distribute the 3 to the 8, so that's going to be 24. And then 3 times 2x. Well, 3 times 2x is going to be 6x, and it's going to be a minus 6x. In this case, we're just going to bring that sign down. We cannot simplify it any farther. We cannot put an unknown, like this 6 times some number, with what we call a constant. So we have to put what we call like terms together. So only x's can go with x's, and constants, which is a number without a variable, goes with other numbers without variables. So if we skip down, for example, to like number 15 all the way down here, we're going to take -2 and multiply it by all of the terms here. So -2 times 2, that's going to be 4x squared. It's a negative times a positive, so it'll be -4x squared. Then we're going to take -2 and multiply it by 3x. So -2 times 3x is -6x. And then the last time, -2 times a positive 1, because you always use the symbol in front of it, -2 times a positive 1 is -2. So just be careful when you're distributing these numbers to make sure that everything inside those parentheses is distributed. It doesn't matter if the number's in the front or the back. Like here we have our y at the end of our terms here. We just multiply everything inside by y as well. So the next one, they are still talking about the distributive property, but now what they're telling us to do is to put like terms together. And so I'm going to put a few notes up here. So any plain numbers like, let me do numbers first. So like 4 plus 3 plus 7, we know that we can add those together because they're all the same. If we have variables like x's, we can add x's with anything else that has just an x with it. So these could be added together. This one, when it's a standalone x, is like the number 1 in front of it. So what we do is we just add what we call the coefficient. So in this case, it's 1 plus 3 plus 5. So we have 9, and then we'd have 9 x's. If we have a variable that has different letters, different exponents. So for example, if we look at number, where's one that I can do that's here, number 11. We have a couple of constants and we have a couple of variables, but these variables are actually different. This right here is an x and this is an x squared. We cannot put those together because those are very different terms. So what we're going to do is we're just going to leave x squared by itself because nothing changes with that. It's a positive x squared because you take the sign in front of it. We also have this minus 6x, so we're going to say minus 6x because there's no other just plain x's that go with it. But then we have this last piece right here where we have a 2 minus 1. So 2 minus 1 is 1, and it's a positive 1, so we would put a plus 1 in between. So what I wanted to show you is you cannot put, like for example, a 9x and 9x squared together. They're two very different things because of that. So you can only combine x squareds with x squareds. You can only combine x's with x's. So just be aware when you're combining these like terms.